In rural areas, ensuring vegetation doesn't encroach into the vicinity of power lines and other above-ground assets is of high priority. We can use Survey 123 for ArcGIS to create an interface to the public that reports hazards straight to those who are responsible for managing them. Survey 123 is a form-centric data capture app that operates online or offline through a browser or mobile app interface. Various question types allow many different elements of information to be captured and attached, including photos, audio, and sketches. The experience of the forms for your users can be enhanced through applying contextual logic, so the form can guide what information people are required to capture. This email notification was created by a crowdsourced incident report Survey 123 form, configured with a webhook. This functionality was released with the latest version of Survey 123. So what are webhooks? Webhooks are a widely supported method used to allow multiple applications to interact with each other, using HTTP POST requests to pass callbacks between them. Common uses for webhooks include sending notifications via email or text, posting messages to social media, automatically writing records to a spreadsheet, and updating enterprise databases. In this case, crowdsourced information has been sent directly to our contractors, responsible for capturing and coordinating the management of vegetation around power line assets. To capture higher resolution geometries, we can use the new functionality inside ArcGIS Online to build our own feature layers from scratch. Whether it be points, lines, or even polygons, we can go through the same process that you'd usually do in desktop tools, however, all within the bounds of ArcGIS Online. This also includes adding different field types. So now that we've created our layer and added it to a map, we can use the new functionality of offline map areas to carry out shelter belt inspections independent of connectivity. So by navigating from the settings of our web map, we're able to manage our different offline areas, this being the title, the level of detail in the download, and even the time that we want this offline map area to refresh. This allows easier management of our map areas for our field workers to access. So now that we've created offline map areas to host the capture of protruding shelter belt features, it's time to enter field operations and begin task management of my inspectors. Workforce for ArcGIS is our spatial to-do list, and as an app has two main components, the web-based dispatcher view and the device-based app for a field worker view. I have specific assignments set up for different operational activities. In this case, I need to dispatch my field worker to perform a thorough survey of the shelter belt in question using the feature layer and offline map areas we have configured. All I need to do is click on the initial report's location and create an assignment, adding in additional context for the job I want my field worker to perform. So in this case, it's to perform a thorough survey of the site that's been reported by a member of the public. After clicking Create Assignment, this immediately sends a notification through to my field worker. As a field worker, when I receive a notification for a new assignment, I can click Start to acknowledge that I'm active and working. Pre-configured app integrations allow all my mobile tasks to be one click away. All the ArcGIS field apps can be integrated to Workforce. However, for this task, I'm going to be using the new version of Collector to collect vegetation infringement information. Collector works anywhere, anytime you need it. Maps can be downloaded to your device and you can synchronize changes when you regain connectivity. A simplified download experience, improved management of offline map areas, and the ability to keep working when you drift in and out of coverage have all been improved with the latest release. There's a better layout to support your workflows. Core tools like Collect are more accessible to promote the scenarios you use every day. There's an overall easier capture of accurate data locations, using these crosshairs that provide a cursor on target experience to precisely define location. You can see that there's a better use of the screen real estate, alternating seamlessly between both form-centric and map-centric views while I'm carrying out an inspection of the shelter belt area. This allows smarter data entry, take a photo in fewer taps, capture additional media, or edit and place on the form, even using things such as a proper keyboard when editing numerical fields. This allows for an improved user experience to capture your geometries and attributes out in the field. So now that I've captured this polygon and I'm back in coverage to sync, Let's head back to the office to see where my captured 2D feature is being used.
So this hazard has been captured on a rural road between two vineyards in Marlborough, and this is our traditional 2D view. However, to understand the full extent of the issue, this might be better visualized in 3D. So we've been able to recreate a realistic simulation of the encroaching shelter belt, symbolize the surrounding vegetation using attribute-driven symbology, and gain a greater understanding of the overall environment, including the modelling of shadows, as you can see here. And by using feature extrapolation, we can turn the polygon captured into a 3D object that provides a lot more context as a hazard to the power lines. Now, only professional utility arborists can cut or trim trees within 4 meters of these type of power lines, shown here in blue. Now, the area around a power line is extremely dangerous. However, the real danger comes with an increasing proximity. So, to provide an incentive for people to keep their trees trimmed, notices are given when they're within an absolute growth limit zone, seen here in orange. So we can see why this hazard was notified in the first place. It clearly intersects that professional high-risk zone. So heading over to the big city, here we have a 3D scene of Wellington CBD, where we've used the new sketch rendering styles to turn these 3D buildings into a more artistic representation of real-world features. As we zoom into street level, you can see we have a number of street furniture points. However, with new symbology libraries added to web scenes, we can turn these bin points into actual bins. So we're building detail from the street up. Now we can complement our scene even more by adding in Wellington City Council's textured mesh, which I was able to access from their open data site. So from humble beginnings, we have an impressive and highly detailed 3D visualization of our city. 3D enhances not only our understanding of the built environment, but the natural environment too, which for Wellington includes faults. So we can take this even further by enabling the new subsurface navigation in our scene, to gain a better understanding of our fault locations and the earthquakes that they produce. We can also access living atlas layers within web scenes, including the new Sentinel-2 imagery. This imagery gets updated regularly, which, depending on where you are in the country, can be as recent as a couple of weeks. So these were just a couple of examples of how 3D can be used to better understand our data through powerful real-world visualization.